So this is GATE 2017 question number 29, which states that water freezes at 0 degrees Celsius at atmospheric pressure, that is 1 atmospheric pressure because it is 1.01 into 10 to the power 5 pascals. The densities of water and ice at this temperature and pressure are given as 1000 kg per meter cube, which is a known value, and 934 kg per meter cube. The density of ice is definitely less than the density of the water. The latent heat of fusion is 3.34 into 10 to the power 5 joules per kg. Let's stop here. One thing which needs to be known here is that the latent heat of fusion or the latent heat of melting are the same thing. 3.34 into 10 to the power 5 joules per kg. One will be with a positive sign, one will be with a negative sign. One is that the latent heat will be absorbed, another is the latent heat will be released. Released means negative, absorbed means positive. The pressure required for depressing the melting temperature of ice by 10 degrees Celsius is, that is, to reduce the melting point of the ice by 10 degrees Celsius, how much amount of pressure, change in pressure is required, that is we need to find out. The answer has to be given in terms of gigapascals, that is 1 gigapascals is 10 to the power 9 pascals. So 1 gigapascal is 10 to the power 9 pascals. We have to give it in that particular form, and up to 2 decimal places we have to give the answer. Okay, so let's see. So we can see that this is something related to the phase transitions. So what are the given conditions are this, that is rho of water which is given, rho of ice is given, T, the temperature is 273 Kelvin which is also given, pressure is the atmospheric pressure which is given, and latent heat of fusion is nothing but latent heat of melting also, and this is nothing but plus 3.34 into 10 to the power 5 joules per kg. Because ice will absorb latent heat and then it will melt into water, therefore it is positive. Melting is the process which is given in the question. That means something which is changing from solid to liquid phase. In this case, it is ice to water. Now, to find the pressure required to depress the melting point of ice by 10 degrees Celsius is the key thing which we need to find out. Since it is involving phase transition from one phase to another, we use the only expression which is very well known for phase transition kind of thing, that how much will be the change in pressure to that of the temperature. This relationship is given by the Clausius-Clapeyron equation. So dp dt, according to the Clausius-Clapeyron equation, dp dt is equal to L from 1 to 2, phase 1 to 2, divided by the temperature at which it is happening, divided by V2 minus V1, where V2 is the higher specific volume. So V2 minus V1 is given. So this V2 and V1, let me write it here. This V1 and V2 are the specific volumes. Specific volumes means anything specific means per unit mass, specific volumes. So we will see that how it is calculated. So 1 to 2, in this case we have already seen that first phase is the solid, second is the liquid. So ice to water. So 1 is ice, 2 is water. Fine. Now we need to find change in pressure corresponding to the dt is equal to minus 10 degrees Celsius because it is depressing. Fine. Now 10 degrees Celsius or minus 10 Kelvin, because it's a change in temperature, both degrees Celsius or Kelvin is same. Now V1 is V ice, as I have told that ice is nothing but the first one, that is 1 upon rho ice, that is 1 upon 934 meter cube per kg. See, density is kg per meter cube. Specific volume, I have already told that specific volume is volume per unit mass. So if we just divide, if we take the reciprocal of density, we get the volume per unit mass unit, a meter cube per kg. Okay. Now V2, that is for the water, it is rho of water, that is 1 upon 1000 meter cube per kg. So V1, V2 we have already found out. Temperature is given, that is 273 Kelvin, that is 0 degrees Celsius. L is the latent heat of melting or fusion with a positive sign. dt is depressing, so minus 10 degrees Celsius or 10 degree minus 10 degree Kelvin. Therefore dp, according to this equation, will be nothing but L, the latent heat, which is positive 3.34 into 10 to the power 5 into dt, which is minus 10. So minus I have taken here, this minus is corresponding to this depression of this temperature, so 10 degrees Kelvin, divided by V2 minus V1, so 1 by 1000 minus 1 by 934 into 273. Therefore, pressure required to depress the melting point by 10 degrees Celsius is given by dP. Now minus I have taken in this denominator bracket, so I have just put the 1 by 934 in this side and 1 by 1000 in this side by absorbing this negative sign. So finally, if we calculate, we get it as 0.173 into 10 to the power 9 pascals. And as the question asks that you have to report it in gigapascals, we know that 1 pascal or 10 to the power 9 pascal is 1 gigapascal. So since we have got it in 10 to the power 9 pascal, so this becomes 0.173 gigapascal. Also, you have to report it in 2 decimal places, therefore 0.17 is the correct option. Sorry, there is no option here, so it's a numerical answer type, so 0.17 should be the answer. So this is the answer. Therefore, the correct option is 0.17. So this is the phase transition question, which involves the Clausius-Clapeyron equation, and we have to give the correct sign also in order to solve this particular question. Thank you.